In this brief video, I would like to look at how to solve a polynomial division problem by making use of the inverse operation of multiplication, which I believe is easier to do, along with guess and check using the answers that are provided on a typical GED or high-set problem. On the screen, we see a typical GED practice problem in which I am asked to find the quotient when the algebraic expression 21x to the 6th power plus 42 times x squared is divided by 7x squared. Now, rather than actually doing a division, what I would like to do instead is make use of the four answers that were given and the inverse operation of multiplication to see if any of the answers that are given when multiplied by 7x squared, the inverse operation of division, gives us the original dividend that was supplied in the problem. So let's see how that would work. First, I'm going to try answer A and see if it works in this case. So I'm going to have 3 times x to the 3rd power, and then I bring the plus 6 over here, separating those two terms out, and then I'm going to draw a grid for showing my work. And then I'm going to separate that. And then off to the left-hand side, I have 7 times x squared. And what I'm going to do is I'm going to use multiplication to see whether the result that I get matches the dividend that I started with. So 7 times 3 is 21. X squared times x cubed is going to give me x to the 5th power. We add the exponents for the variable when we do the multiplication. Moving to the next square, I'm going across the row and vertical from the column, and I'm multiplying those two terms where they intersect. So 7 times 6 is 42. That's a plus 42 because they were both positive values. X squared just stays as x squared. There's no x terms attached to the 6 that need to be multiplied by the x squared. And I now have my subproducts that resulted from multiplying the column and row terms across and down. I now combine the subproducts together to get my total, which is 21 x to the 5th. I'm leaving off the dots in between that designated multiplication at this point using standard notation, plus 42 x squared. And I can see that this does not match the original dividend that I started with. It's not 21x to the 6th plus 42x squared. Therefore, answer A cannot be the possible quotient that would have resulted from the division. Not only that, we have a little more information. We can see that this doesn't differ from the original dividend by very much. In fact, only the x to the 5th and the x to the 6th are different. That means that probably comparing answer A and answer C together, this might be the correct answer because this has a slight increase in the exponent, which is what I needed to make it work. Let's double check that assumption. So now I'm going to take 3x to the 4th power plus 6. I'm using answer C now to see whether this will result in the original dividend that we were given when I multiply that by 7x squared. 3 times 7 again is 21. X squared times x to the 4th is x to the 6th. 7x squared times 6 is 42. X squared, I add the pieces together to get my complete product. And when I do so, I find that this matches the original dividend I was given in the original problem statement, and therefore showing that answer C is indeed the correct answer in this case.